A graph consists of points called vertices and also consists of edges, which are segments that connects every two adjacent vertices. The vertices in our graph here are the points A, B, C, and D. And the edges, and keep in mind the edge doesn't have to be straight, it can be curved, and the edges are AB, AC, AD, BC, BD, and CD. So these are the edges. Equivalent graphs have the same vertices and the same edges connecting the same vertices. So you don't have to look alike. So an equivalent graph to the one we have is as follows. How do we draw an equivalent graph? So we have a graph here. So first we're going to draw the vertices. And since we have them in the given graph collinear, so we're going to draw them non-collinear in the second one. Now we're going to connect the edges starting from A, and we need to respect the other vertex. Now we're going to connect the edges starting from B, starting from C, and starting from D. So the graph we draw is equivalent to the given one. The degree of the vertex is the number of edges issued from that vertex. So the degree of A is 5 because we have 5 edges starting from A. The degree of B is 3 because we have 3 edges starting from B. Similarly to the others, the degree of C is 5. The degree of D is 3. And the degree of E is 4. If the degree of a vertex is odd, we call it an odd vertex. If the degree of a vertex is even, we call it an even vertex. We can represent floor plans with graphs. We're gonna represent the rooms with vertices. Also, the outside would be represented with a vertex. Now, if two rooms share a common door, we can draw an edge from between these two vertices. And don't forget also, if a room has a door to outside, we can connect that room with the vertex outside. So this is the graph of the floor plan we have. We have Kongsberg map, and we can model this map with a graph. We're going to represent the islands with vertices. And if two islands share a bridge, we can draw an edge between these two vertices. And that's how we model Kongsberg bridge or graph. Also with maps, we're going to represent the states with vertices, and if two states share a border, we can draw an edge between the two states. A path is a series of adjacent segments starting at one vertex and ending another one. An example of a path is as follows. So we're going to start at C and end at E. A circuit is a series of adjacent segments starting at one vertex and ending at the same vertex. So we're going to start at C. We're going to see an example of a circuit. So we ended up at C. In other videos, we're going to talk about Euler circuit, Euler path, Hamilton circuit, Hamilton path, and we're going to talk about trees and spanning tree. So more concepts are coming soon.